Students, welcome once again to the Owl Academy of Education. In today's video, we are going to start here with ICSE Class 7 Maths. ICSE Class 7 Maths chapter is chapter number 6, that is sets, right? So sets is a good chapter. Let us start it. So how to first of all we will see what is a set. A set, a well-defined collection of objects, is called a set, right? The objects in a set are called its member or element. They can be called members or elements or points. So sets are always denoted by the capital letters A, B, C, D and E, A, B, C, D, E, etc. and their members by small letters A, B, C, D, X, Y, Z, etc. Right? Now, how can we represent these sets? If X is an element of A, we write it as, if X is an element of A, we write it as X set A, right? This is representation of it. X belongs to A, which means X belongs to A. If X is not an element of A, we write it as X is not an element. We cut it from here, which means X does not belong to A. Elements of sets are put in without brace brackets, like it. These are separated by commas. For example, let A be the collection of all prime numbers between 50 and 70. Write in the form of set. So we have to write them in the form of sets. So we know that all the prime numbers between 50 and 70 are 53, 59, 61, 71. 53, 59, 61 and sorry, this 71 is not there, 67 would be there, right? So what are prime numbers? The numbers having only one as their factor. So these are, we will represent them in the form of set. This is the form of set. A equal to, within brace brackets, these are elements of A. So if we want to represent each element of A, we will write them as 53 belongs to A with this symbol, 59 belongs to A with this, 61 belongs to A, 61 is there, but 71 is not there. Here is 67. So we will, it does not belong to it, so we will write the symbol and cut it. Right, this means 71 does not belong to A. In the same way, if you take another example, is collection of 4 days of a week a set? There are 7 days in a week, but here only 4 days are given. So these 4 days are not first 4 days of the week or last 4 days of the week. This is not a set because we are not definite about the objects of this collection, right? If he would have given the first 4 days, then we would write it as Sunday, Monday, Monday, Tuesday, Wednesday, Thursday, right? In the same way, if terms like tall boys in a class, beautiful girls in a class, honest persons in a society, bad boys, intelligent, means these words are carrying abbreviations like tall, honest, bad, intelligent, brave, faith, thin, etc., interesting, difficult, they do not form the sets, and they also not represent the sets, right? Now next, these are vague terms. Now we will move on to the next page. This is how to describe a set. There in mathematics there are three methods to describe sets. These are, number first is roster method or tabular form. In this method we just make a list of the members of the set and then put it in the within the braces or brace bracket. The elements in the list can be written in any order. Irrespective of their order, they can be written in any order. Every repeated, if any word or letter repeat, it is taken as only once, right? For example, let M be the set of letters of the word professor. So in this professor word, there are repeating words O, right? R, S. So we will take them only once. So P is only one, R is two times, we will take one time, O is single time, F is single time, E is single time, S is two times. So we will take only one time, right? Or orders these in orders of these can be written in any way, right? So these can be also written as S, E, F, O, R, P, irrespective of their order, but they have to be taken only once, right? Now second is description method. In this method we just give a description of members of the set and put them within the braces. For example, let A 31, 37, 41, 43, 47, right? So A in description method can be written as these are prime numbers more than 30 and less than 50. So our set would be A equal to prime numbers between 30 and 50, not included 30 and 50, between 30 and 50, right? Now third method is rule method or set builder form. It is a complex, complicated method. In this method we list the properties which are satisfied by each element. So these properties should be satisfied by each element. Here we write X colon X has properties P. So what would this mean? This would mean the set of all those X, the set of all those X such that X has properties P, such that X has set of all those X such that this column means such that X set of all those X such that each X has properties phi, right? For example, letter A, if we write, take an example, these are 11, 13, 17, 19, 23, 29. So these are all prime numbers more than 10 and less than 30. So in set builder form we would write it as A equal to X, right? A equal to brace within brace X is here we write A equal to the set of all those X such that X is a prime number between 10 and 30, right? Here this would become greater than 10 and this would become lesser than 30, right? So this is a complex, understood it well, understand it well, then you could do the sums easily. Now, types of sets, there are a lot of types of sets. Number one is finite set. As its name indicate, finite means a set having definite number of elements is called finite set. For example, all sets of a natural number less than 100. We definitely know that which numbers are natural numbers are less than 100, right? Set of all trees on the earth, right? Counted. Set of all mountains in the world, they can also be counted, right? So they are finite sets. Infinite. Now second set is infinite set. Infinite set means a set having indefinite, which cannot be counted, indefinite or which cannot be counted number of elements, that is infinite set. For example, set of all number greater than 100, they are many and many, they can't be counted, so we put them in the infinite set. Set of all points on, this is not t, this is the, on the arc of a circle, on the arc of a circle there are many points, indefinite number of points. In the same way, set of all points on a line segment, right? Or we can write it as n equal to 1 2 3 4 5, set of all natural numbers. It can't be, and they are indefinite, can't be counted, so they are infinite sets. Number third is empty or null sets. As it is, number is indicating that there would be no element. The set having no element is called empty or null set or void set, right? It is represented by the mark, this 5. We read it as 5. In roster method, it is if the blank brace bracket would mean empty or null set. For example, x colon x set n belongs to n represents the set of all natural numbers lying x, all natural numbers between 2 and 3, and there is no natural, but as there is no natural number between 2 and 3, so it is 0, so it is an empty set. The empty set is a finite set, as this is not the, this is the, as number of elements contained in an empty set is always 0. Next we will move on to singleton set. A set having only one element is called a singleton set, as its name represents single. So for example, if we write uh, for example, if we write x, the set of all those x such that each is an even prime number. So there is only one even prime number, that is 2, right? Even prime number. So only one element is here, so it has become singleton set, right students? Now next we will move on to equal sets. Two sets A and B are said to be equal if every element of A is in the B and every element of B is in A. So we write it as A is equal to B. For example, if A minus 3 minus 2 minus 1 0 1 2 3, so these are what? These are all integers. So we will read it as X, how we will read it as? We will read it as the set of all those X such that each X is a integer, each X is a integer, and each set is a integer, and this is X. This has written x2, but this is not x2, this is x square. X square less than 16, right? So here these are square digits. 3 3 are 9, minus 1 plus 2 2 are 4, 1 1 are 1 0 0, 1 1 are 1, 2 2 are 4, 3 are 9, but they are all less than 16. That means 4 has not been included in it. So these are equal sets, right? In A, all these numbers are taken. In B, this has been written in the set builder form, right? Next is, what is cardinal number? Cardinal number, the number of distinct elements contained in a finite set A is called its cardinal number. We will count the first condition in this is first of all, it should be a finite set. That means its number of members could be counted. Like this, A is set 2, 3, 5, 7, 11. Here there are 5 elements, 1, 2, 3, 4, 5. So its cardinal number would be n within round bracket A equal to 5. As it has 5 elements in it. Right, so its cardinal number is 5. Cardinal number is always written in this way, n round bracket 5. This is it. Now equivalent set. Here these all the above 5 sets were single sets, right? Now these sets comes in pair from 6. Number first 6 is equivalent set. Here 2 sets above were only one set. Two finite sets A and B are called equivalent if they have the same number of elements, and we write them as E. This is its symbol. Thus, whenever our cardinal numbers of two sets will be equal, then they would also be equivalent sets, right? So next is, for example of equivalent sets. For example, let A is the set of vowels in English alphabet and B the set of first 5 natural numbers. So this is the set of vowels in English alphabet. There are 5 vowels, A, E, I, O, U, and B is the set of first 5 natural number, that is 1, 2, 3, 4, 5. It is clear that in this there are 5 elements, 1, 2, 3, 4, 5. In it also 5 elements, so equal, their cardinal number is equal, that is 5. Therefore A is equivalent to B, right? Here please note that two sets are always equivalent. Two sets are always equivalent, but two equal sets are always equivalent. The two sets which are equal, that is same number of having same number of elements, are always equivalent, but two equivalent sets need to be not to be equal. Two equivalent sets are not equal. For example, if I write A equal to ABC, B equal to 1, 2, 3, these are equivalent sets, but not equal because no element is equal between them, right? Number 7 is disjoint sets. Two sets having no element in common are disjoint sets. For example, A equal to 1, 3, 5, 7, B equal to 2, 4, 6, 8, 10. A and B have no common elements, so there are disjoint sets. Overlapping sets. Two sets A and B are overlapping sets if they have at least one element in common to them. For example, let A 2, 3, 5, 7, 11 and B equal to 2, 4, 6, 8, 10. Here 2 is common in between them, so they are overlapping sets. Right students, now we will move on to your we will solve your exercise 6a. So 6a is what? So first question is, which of the following collections are sets? You have to find out, are they sets or not. So first is all books in your school library, so this can be counted, and no vague word is in it, so it is set. Yes, set. Are red flowers in a park? Yes, can be counted, no vague item in it, and they are they are sets. I will rub it. So they are sets. Yes, right. Now all good players, here it has one vague item, good, so they are not, so it is not an set. Now all fiction movies, number 4, all fiction movies can be counted, so and it has no vague word in it, so it is a set. Yes. All easy problems in your book on mathematics, all easy, it has one vague word, so it is not set, not. All poor people in Mumbai, all poor people in Mumbai can't be poor, it has poor vague word, so it is not an set. All boys in your class weighing less than 50 kg, they can be counted, no vague item in it, so it is a set. Yes. All person of repute in your locality, all person of repute is a vague word in terms of set, so it is not a set. Question number 9, part 9, all even number greater than 100, all even number greater than 100, yes, no vague word in it, it is a set. All integers less than -5, so it is also a set. Right students, now we will move on to the next part. Question number 2, write each of the following sets in roster form. A set of all prime numbers, A is a set of all prime numbers between 70 and 100, so it is quite easy, we can write it as a equal to, within brace, 71 prime numbers between 70 more than 70 less than 100, 71, 73, 79, 83, 89 and 97. These are all prime numbers. B is a set of all whole numbers less than 8, not including 8, so B would become B equal to, within braces, 0, 1, 2, 3, 4 whole numbers, set of all whole numbers, 1, 2, 3, 5, 6, 7, set of all 1 2 3 5 1 2 3 4 5 6 7 all whole numbers less than 8, that is including 0. Number third is set of all integers like between say, -7 and 2. You know the integers c equal to -7, so we will take -6, -5, -4, -3, -2, -1, 0, 1. Composite numbers. D is a set of all composite numbers, so D would be equal to all composite number means greater than 23 less than 32. So 24, 25, 26, 27, 28, 24, 25, 29 is a prime number, 30 and 32. So E is a set of all letters in the word mathematics. The words which are repeating, we will left them. So which is repeating? T. T is repeating here. M is also repeating here. So we will take only M, A, T one time, H, E. A is also repeating. So M, A, put comma between them. M, A, T, H, E, I, C, S. This is our. So F is a set of consonant in the word secondary. So secondary, first of all see the repeating words, which is consonant, only consonant we have to taken. So S is a consonant, C is a consonant, N is a consonant, D is a consonant, R is a consonant, Y is a consonant. These are vowels, E and A and O, these are vowels. So we will take only consonant, S, C, N, D, R, Y. Right, students? Now G. G is a set of vowels in the word. Here we will take only vowels. I is a vowel, E is a vowel. E has 2 times, but it will taken 1. I is also 2 times. A, E is also 3 times. So we will take only I, E, A. So I, E, A. So students, this is our second question. Write each of the following sets in the roster form. Now question number 3. In the roster form. Question number 3. Write each of the following sets in the roster form and write the cardinal number of each. So first here is A equal to X is such that X is an integer. Here -3 less than X less than equal to 4. So how we will read it, this set? So first of all, your method of reading the set should be correct, right? It is given in the set builder form, but you have to write it in the roster form. In the set builder form, if you have read the set correctly, then you are going to get okay results, right? So first of all we will read it. So this is X, the set of A is the set of, I am going to write it here as, so that you can understand it easily. A is the set of, A is the set of all those X. A is the set of all those X. Right now this is such that, this is first X, all those X, such that each X has, so such that each X is an integer, X is an integer more than -3 and less than more than minus, X is more than -3 and here X is less than, and this they have put here, this means and equal to 4. So you will read this set builder form in this. This is only for your understanding, not to write here, or you can write it here for your convenience. Right now we have read it. A is a set of all those X such that each X is an integer more than -3 and less than and equal to 4. Right? So what would be our roster form? We will write it. This is your answer. A equal to, within braces, more than means more than, in minus the letters smaller are bigger than, so -2 is greater than -3, -1 is also greater than, 0 is also greater than. Now integers hai, so 1 2 3, and this is less than and equal to means if only less than, then 4 would have not been included in it. Now it is also equal to 4, so we will take 4 in our answer. This is our answer. Now he has asked cardinal number. So for cardinal number, and as here set is A and all the elements of A are count 1 2 3 4 5 6 7. There are 7 elements in it. We will write 7 here. So this is our part first of question 3. Right, students? Now we will take second part of it. Second part is, what is second part saying? Second part of question third is saying B equal to B is a set, is how we will read it. B is a set of first of all let me write it. B x such that x is a set of n means capital N means natural numbers having properties 3x minus 6 less than 9. So how you are going to read it? First of all, understand it. B is a set of all those x such that each x has such that each x such that each x is a natural number a natural number having property 3x minus 6 less than 9. So what does it means? So the x is a natural number, so we will put let x equal to 1 in 3x minus 6. So we will get 3 multiplied 1 minus 6 equal to 3 minus 6 equal to minus 3, which is less than 9. So it is okay. We will now x equal to 2 in 3x minus 6. We will get 3 into 2 minus 6 equal to 6 minus 6 equal to 0, which is also less than 9. This is also included, that means x is our answer, 2 is also our answer. X equal to 3 in 3x minus 6. 3 multiplied 3 minus 6 equal to 9 minus 6 equal to 3 is less than 9. So we can take it. X equal to 3. X equal to 4 in 3x minus 6. That means 3 multiplied 4 minus 6. That means 12 minus 6 equal to 6, which is less than 9. X equal to 5 in 3x minus 6. 3 multiplied 5 minus 6. That means 15 minus 6 equal to 9, which is equal to 9. We have to take only less than 9. No, this is not. So our answer would be, therefore B in roster, this is set builder form. In roster form it would be B equal to 1 2 3 4. Our answer would be B equal to 1 2 3 4. its cardinal number NA would be, count elements 1 2 3 4 4. This is our required answer. Now it's part third. Move on to part third. What is part third saying? Part third of it is saying C equal to x such that equal to n square n set and 10 is less than n is less than 60. N is greater than 10 and less than 16. So how we will write it? So C is a set of all those x such that each x is n square, each x is having property n square and having property n square and n is more than 10 and 10 but less than 60, right? So we will put this is okay, more than 10 and less than 16. That means 10 and 16 will not be included in our answer. So it is quite simple. More than 10, 11. So it is square property. It is having property n square. So 11 would be square of 11 would be 11 ja 121. Next is 12 ja 144. Next is 13 ja 169. Next is 14 ja 196. Next in 15 ja 225. And our cardinal number NC would be, how many elements we have calculated? 1 2 3 4 5, and C would be 5. So student, this is your part third. If you have understood the if you have understood the roster form, set builder form well, then you can easily write it in the set builder form. This was third. Now we will move on to the fourth. So fourth, what is fourth part is saying? D equal to x is such that I write it in the form of E, but it is not E. It is like this. Sign of x is like this. So fourth, x is a whole number. W means whole number having property x minus 3 less than 2. So this is just like question number 2, right? You can do it, or I am going to do it, right? Now how you will study understand it. D is a set of all those x such that each x is a whole number having property x minus 3 is less than 2. So let it is a whole number. Whole number will be started from 0. So let x is equal to 0. Therefore x minus 3 would be 0 minus 3 equal to minus 3, which is less than 2, right? Which is less than 2. And now x equal to 1. Therefore x minus 3 would be, put 1 in place of 3, 1. This is minus 2, which is also less than 2. This is satisfying our condition. This is satisfying this condition. So x equal to 2. Therefore x minus 3 would become 2 minus 3, that means minus 1. So it is also satisfying our condition. Minus 1 is less than 2. Now put x equal to 3. Therefore x minus 3 would become 3 minus 3 equal to 0, which is also less than 2. X, it is also satisfying our condition. X equal to 4. Therefore x minus 3 would become 4 minus 3 equal to 1, which is also less than 2. So it is also satisfying our condition. Now x equal to 5. Therefore x minus 3 would become 5 minus 3 equal to 2, which is equal to 2. So this is not our required condition, not. So therefore if we write D in so students, if I write D in the roster form, this would become 0 1 2 3 4, right? And our cardinal number would become ND equal to 4. This is our required answer, right? Now move on to the next, that is part 5. Question 3, part 5. So part 5 is E equal to x is such that part 5. Sorry, I have written part 6. So E equal to x is to x is such that 2n minus 1 comma n is a natural number. N is stand for natural number and n is less than 6. So students, this question is just like question number part 2, just like part 2. Part second. So this is your homework. Do it at home. If you will face any problem, then go to our comment section. Now we will move on to sixth. Sixth is f equal to x is such that x is a letter in the word common. Right, students? Now this is quite simple. Common have two m's, we will take 1m, 2o we will take 1o, right? Therefore in in roster form it will be written as equal to what? COMN, and its cardinal number would be NF equal to 1 2 3 4 4. So question part 7th, primary color, you know, red, blue, yellow. So this is your homework. Part 8th, H a digit in numeral 231 236. 2 here we will take 236 only. 2 is written 2 times, so this is also your homework. And sorry, I will write part 9th here. In 9th, what is he saying? J is equal to x is such that x equal to 1 upon n, and this n are natural number which are 4 less than, more than 4 and less than 10, right? So this is quite simple. J equal to 1 upon n, 1 upon less than, more than 4, 1 upon 5, 1 upon 6, 1 upon 7, 1 upon 8, but less than 10, 1 upon 9. So their cardinal number would become 1 2 3 4 5, right? Now so students, this was question number 3rd of your exercise 6th A. We will do the remaining questions in the next video. Thanks for watching the video. If you face any problem, Please discuss it in our comment section. If you had understood the lesson well, then make more and more likes and shares and get our channel subscribed by more and more of your friends. Thanks. Till the next video, it's goodbye.